Comparison testing of soldering irons. Some of the tests we use when evaluating soldering irons. Temperature overshoot and temperature stability. Is the temperature on a dial or a display the actual tip temperature? Load testing of the iron. How well the iron supplies heat to the tip during soldering. Tip life testing. How long will a soldering tip last before the plating is worn through? This is a comparison of an OKI PS900 with smart heat technology versus a conventional soldering iron. How to measure the tip temperature of a soldering iron. Use a small sheathed thermocouple. Drill a small hole near the end of the tip going halfway through the tip. The diameter of the thermocouple sheath is 1/2 millimeter. Turn on the iron and apply a very small amount of solder to fill the hole, and insert the thermocouple. The solder will provide a good thermal path from the thermocouple to the tip. Attach the thermocouple lead securely to the handle of the soldering iron so that the thermocouple does not come loose during measurement. Here the PS900 power supply has just been turned on, and we are monitoring the tip temperature and the watts that the power supply is consuming. On the bottom you can see the tip temperature displayed in degrees centigrade. On top is a power meter displaying the number of watts that the power supply is consuming. When the unit was first turned on, the power consumed was 70 watts with a cold tip. As the temperature of the tip rises, the amount of power consumed is decreasing. When the tip comes to full heat of about 360 degrees, the power consumed will be 17 to 18 watts with no load on the tip. Here we see a conventional iron just after being turned on. The power supply for this iron has a temperature display. But if you watch carefully, the temperature read by the thermocouple is much higher than the temperature displayed by the power supply. Also note the power being consumed by this iron. It takes 200 watts to heat this tip to soldering temperature. The thermocouple temperature climbs over 410 degrees, while the temperature displayed by the power supply is about 350. The display temperature is not the actual temperature. The actual temperature can vary by many tens of degrees from the displayed temperature. Here we have dynamic load testing. There are 10 copper slugs, each fitted with a thermocouple. Each copper load will be heated until it reaches 250 degrees centigrade. The load is sized to require about 10 seconds of heating to reach 250. We are checking that the power supply can heat all 10 loads without requiring more time to heat the last loads in the test. We're also making sure that the stored heat is not being used to heat each of these. We're making sure the power supply cycles each time. We are also watching how much power is required to do this. The PS900 is consuming about 40 watts to bring each load to 250 degrees at 10 seconds per load. Here is the conventional iron going through dynamic load testing using the same loads as before. It is also taking 10 seconds per load to heat each load to 250 degrees centigrade. However, the power consumed is varying from 30 watts to 200 watts as the power supply cycles and attempts to keep the tip at soldering temperature. Tip life testing. The iron is held in a mechanical fixture. A measured amount of solder is fed directly onto the tip of the iron. Fixture lowers and wipes the tip off in a sponge. Fixture rises, another measured amount of solder is fed directly onto the tip. This process of feeding solder, wiping it off, feeding solder, wiping it off, is continually repeated until a hole is worn through the plating of the tip. At that time, the total time in the machine and the amount of solder required to create the hole is recorded. In conclusion, this conventional iron suffers from severe temperature overshoot. The temperature displayed on the iron's power supply very quickly settles to within a couple of degrees of the temperature set by the operator. But the actual tip temperature can be up to 60 degrees higher than the display. This discrepancy between actual and displayed temperatures misleads the operator and can adversely affect temperature-sensitive components. For more information, please contact OK International's Technical Support Group. The email address, support@okinternational.com.